So in this unit, this is unit 5, which is called analytic trigonometry, right? And so basically we're going back to trig, except in this unit we're less interested in computing trig functions themselves, and we are more interested rather in looking at the properties of the trig functions algebraically. So in this unit there's a lot more algebra and a lot less kind of pure trig, if that makes sense. You'll see what I mean. So the title of today's lecture is 5-1, Using Fundamental Identities. If you're seated awkwardly, feel free to rearrange the tables as long as you move them back. Okay, so the good news is that a lot of the identities that we're learning today are things that we've already learned. The only problem is that now we need to commit them to memory. On the test, there will be no equation sheets. I don't believe in those. No equation sheets, no calculators. Okay, so the first is the Pythagorean identities. And we call these Pythagorean identities because they can be derived very easily from the Pythagorean equation. So the first one we've already learned. This is pretty ingrained in our memories. Sine squared plus cosine squared equals 1. Okay? So that's true for any value of x. Sine squared x plus cosine squared x equals 1. And so that's the first one. The second one, maybe some of you guys have this memorized. 1 plus tangent squared is equal to secant squared. Okay, 1 plus tangent squared equals secant squared. And this is very easy to derive. All we do is we go back to the sine squared plus cosine squared, and we divide both sides by cosine squared. Right? If we divide left and right side by cosine squared, then the left side becomes tangent squared plus 1, and then the right side becomes secant squared. Make sense? Right? Because sine squared over cosine squared is tangent, and cosine over cosine is 1. 1 over cosine is secant. Any questions? Okay, well, the third Pythagorean identity is very similar. It's just 1 plus cotangent squared equals cosecant squared. And this can be derived pretty much in the exact same way, except now we divide both sides by sine squared, which makes the left side become 1 plus cotangent squared, and the right side becomes cosecant squared. Okay? So, when I was in pre-calc, I didn't even bother memorizing these because they're very easy to derive. But maybe memorizing them would be a good idea, just so that it comes more naturally. Thankfully, it's pretty easy to memorize. You just need to remember two things. The first thing is that the tangent is always with the 1. Okay, so tangent goes with the 1, and cotangent also goes with the 1, right? So they're kind of both tangents, so they go to the 1. And then the second thing to memorize is that the c's are together, right? Cotangent goes with cosecant. And if they're not c's, they also go together. Not c's. I don't know. I was just noting how they sounded similar for some reason. Okay. Okay, any questions? So tangent goes with secant, cotangent goes with cosecant, and the tangents always have the 1s there. Any questions? All right then. We do have more to memorize. But the good thing is we already memorized them. We also have cofunction identities. So if you guys recall from 4-3 or something, we memorized these things called cofunction identities. That is, sine of pi over 2 minus x is equal to cosine of x. In other words, cofunctions of complementary angles are equal to each other. So pi over 2 minus x and x are complementary angles because they add to 90 degrees, right? Pi over 2. Complementary angles. You guys know how to spell complementary? It's not an I, it's an E. Complementary. Okay, likewise, cosine pi over 2 minus x is equal to sine of x. Okay, and then you might be asking, what is a cofunction? Well, a cofunction is just the whatever function has a co in front of it. So sine goes with cosine, and tangent goes with cotangent. Secant goes with cosecant. So these same relations also apply for tangent x. I'm just going to write it like this. Tangent goes with cotangent, and secant goes with cosecant. And the same exact relations apply. So like tangent of pi over 2 minus x is cotangent of x, etc. Questions? Okay, doesn't stop there. We have more to memorize. The last thing is even and oddness. But the good news is we already kind of learned this, right? Anybody remember whether sine is odd or even?
Odd.
Odd, very good. So we have to remember that sine is odd. So that means sine of minus x is equal to minus sine of x, right? That's what it means to be an odd function. When you plug in a negative x, you get a negative of the original. So sine of negative x is negative sine of x. And cosine is even. Even means that it stays the same when you plug in the negative x. Right? It's very even. Whereas odd is very odd. Changes. Okay, so cosine of negative x is equal to cosine of x. Yep.
Is tangent also odd?
Tangent is odd. Okay, sine is odd and cosine is even. That means tangent is odd. How do I know that? Well, tangent of negative x is simply equal to sine of negative x over cosine of negative x, right? Right, because tangent is sine over cosine. But sine of negative x is negative sine of x, whereas cosine of negative x is cosine of x, because sine is odd and cosine is even. But that's just equal to negative tangent of x. So that's a simple proof for why tangent is odd. Any questions? So tangent is odd. Let me erase this proof. So tangent is odd. And then the corresponding reciprocals obey the same properties. So if sine is odd, that means cosecant is also odd. And if cosine is odd, that means secant is odd. Sorry, cosine is even, that means secant is even. And then if tangent is odd, that means cotangent is odd. All right, any questions?
Will we have to be graphing anything? Or will we be graphing this unit?
Nope. Save that for the final. Any questions? This is the extent to which you need to memorize today. We'll be memorizing more in section 4.
Is that next class?
No. We're on 1, right? So 1, 2, 3, 4. It'll be in 4 classes.
Which one are we in?
5-1. Huh? Okay. Yeah, nice. Yeah. Yeah. So I'm only going to make you memorize what I also memorized when I was in high school, okay? So there are some equations in this unit that I didn't memorize either, so I won't make you memorize those. I'm just holding you to the same standard I held myself to.
What is the standard that the class?
Whatever's in the textbook.
So why don't you hold us to this one?
Okay, I'll make you memorize more than I memorized then. Okay, let me go through some example questions, because today is not just all about memorizing equations, we also have to know how to use them. So let me go over a first example from the textbook. Let's say we're given secant of u. I don't know why the textbook likes to use u. Okay, let's say secant of u is -3/2. And we also know that tangent of u is less than 0. Sorry, greater than 0. The next question has us finding the values of all 6 trig functions based on these 2 facts. Okay, and so in the previous unit, what we would have done is used a right triangle and thought about which quadrant this was in, right? So secant is negative, tangent is positive, that means it's in quadrant 3, and then we would have done that, etc., etc. But in this unit, we're going to try and use the identities and do this using only algebra instead of thinking about the unit circle, because we really hate the unit circle. Algebra is much easier. So the first thing we should think about is first, which equation we just memorized that involves the information that we know. And if we look back and think with our minds, then we can clearly see that the equation we should use is 1 plus tangent squared equals secant squared. So if we wrote that, then we would find that 1 plus tangent squared of u is equal to secant squared, which is 9/4, right? 3/2 squared is 9/4. And so that would tell us that tangent squared equals 5/4. Okay? Any questions? And so now we can take the square root of both sides. And because tangent is positive, we choose the positive root. So that means tangent of u is equal to √5/2. And that's one function down. 4 to go. √5/2. Is it wrong?
Gotcha.
Okay. Secondly, if secant is -3/2, well, that means cosine is also very easy to find, right? Cosine u is simply going to be the reciprocal of that, which is -2/3. Okay, so that's 3 functions, 3 to go. Okay. Well, how do we find sine if we know cosine? We're just going to use the Pythagorean identity again, right? So sine squared plus cosine squared, which is 4/9, is going to be equal to 1. Sine squared plus cosine squared equals 1. And so that's going to tell us that sine squared u is equal to 5/9.
How did it go from 4 to 5?
1 minus 4/9 is 5/9.
Okay.
Okay? Now, is sine positive or negative? Very good. It's negative. The reason why it's negative is because tangent is positive. Right? Tangent is equal to sine over cosine. So if tangent is positive and cosine is negative, that means sine also has to be positive, right? Sorry, negative. Because minus over minus is plus. So that means we have to choose the negative root of 5/9. You have to be very careful with the signs here. Because if something squared is positive, that doesn't mean it's positive, it could be negative. And so in this case, we have to choose the negative root. So sine is -√5/3. Okay? Any questions? Must pay attention to the signs. And the question will always give you some kind of condition that will help you, such as here it gave us tangent is positive. Questions? Okay. Last two can be determined simply by doing the reciprocals. So cotangent is going to be the reciprocal of tangent, which is 2 root 5 over 5. Remember to rationalize denominators.
So those are both valid answers.
What is?
Those two things you just circled.
No, they're different, right? The right side is cotangent.
So which one's the correct answer?
They're both correct.
Oh, that's what I just asked. Like, they're both valid answers.
Yeah, they're not the same thing. I'm not sure what you're asking. Yeah, we're looking for all 6 trig functions, right? So knowing tangent gives us cotangent. And then knowing sine gives us cosecant. So cosecant u equals negative 3 root 5 over 5. Any questions? Yeah.
Why did you use 4/9 instead of cosine?
Yeah. Sine squared plus cosine squared, right? Any questions? I'm moving on. Yep. Let's do the next example. The next example has us simplifying something. So the question is, please simplify sine x times cosine squared minus sine x. Okay? Simplify sine x times cosine squared minus sine x. So in these questions, typically the best first step is always to factor. Factoring, algebra, right? So in this case, we're going to factor out a sine x from both terms. And we're left with sine x times cosine squared x minus 1. All right? Divide both terms by sine x and extract that factor. Okay. Well, now, how do we simplify cosine squared? Well, we should use the formula that we know, right? Sine squared plus cosine squared is 1. So that tells us that cosine squared is 1 minus sine squared. And that's something that we can plug into the thing that we have. So this we can simplify as sine x times 1 minus sine squared minus 1, right? Because cosine squared becomes 1 minus sine squared, and then that minus 1 follows. And so if you simplify this, the 1 and the minus 1 cancel, and we're left with negative sine cubed x. That's pretty simplified, so that's our answer. Any questions? So it's good to always factor first, and then try to see if you can use a Pythagorean identity somewhere. Questions? Last one, then classwork. Last one has us simplifying sine theta over 1 plus cosine theta plus cosine theta over sine theta. Okay? So this is really all just algebra, and then we just use an identity when it's helpful for us. So to add these two fractions, that's usually the best first step. We just cross multiply. So that becomes sine squared theta plus cosine theta times 1 plus cosine theta, right? In the denominator, we multiply those, so it becomes 1 plus cosine theta times sine theta. And then the top, we can now expand. But the bottom, I'm going to leave the same. So the top, I can expand as sine squared plus cosine theta plus cosine squared theta. Right? I just expand this term here. Cosine theta times 1 is cosine squared times, yeah. So that's what I'm left with. And then the denominator, I'm going to keep the same. Okay. The reason I know that I want to expand the top but not the bottom is because I know that if I expand the top, I'm going to be able to simplify. The reason is that expanding will give me that cosine squared that I really want, right? Because if I have a sine squared here, I really want to have a cosine squared as well, because that will collapse into a 1 by the Pythagorean identity, which is exactly what I'm going to do. So the sine squared and the cosine squared, if they're added together, that's just going to give me 1, right? So it's going to be 1 plus cosine theta over 1 plus cosine theta times sine theta. Is there a question?
How did you get the denominator when you cross multiply again?
You multiply
It's just
the
adding
denominators?
fractions. Yeah, multiplying denominators.
Oh, you just multiply the denominators.
Right, if you're not familiar with that, just think about, right, we're just multiplying the right fraction by 1 plus cosine theta over 1 plus cosine theta. And the left fraction is being multiplied by sine theta over sine theta.
Gotcha.
Okay, so the final answer is 1 over sine, which is just cosecant. Because the 1 plus cosine theta cancels out from the top and the bottom. Any questions?